Hi, I'm Hayne, and today I'm gonna talk about memory devices. Before we talk about memory devices, we have to know the basic architecture of the memory. Uh, in memory, some data are served at the storage area, and around the storage array, there are some supporters. It is called pericircuits, and in pericircuits, the data are decoded and sensing and amplified. Okay, then now we will talk about the memory devices. In semiconductor memory devices, there are representatively two groups. The one thing is random access memory, which is called RAM, and the other is read-only memory, which is called ROM. The representative characteristic of the RAM is volatile. If you off the power, the data are erased. In RAM, the representative device is SRAM and DRAM. First of all, we will talk about the SRAM. The full name of the SRAM is the Static Random Access Memory. Let me see. This is the architecture of the SRAM. SRAM is consist with a latch and a switch. So you can make this circuit with the transistor. So if you want to make the SRAM, you need to use 6 transistors. Uh, the most important characteristic of the SRAM is that it's so fast at reading and writing. But there are some disadvantages too. The SRAM needs at least 6 transistors, so the layout is so mass, so it is difficult to increase the density of the chip. And second thing we have to know about the DRAM. DRAM is the dynamic RAM, and this is the main structure of the DRAM. You can make the DRAM with one capacitor and one transistor. So DRAM is more smaller than the SRAM, and you can increase the density of the devices. The basic principle of the DRAM is like this. When the transistors are connected, it means the switch is on. The data moves to here and the capacitor is charged. So if the capacitor is charged, it means the data is written. And if you want to read the data of the capacitor, you have to connect the wire line once again and read sense the data in capacitor. The most important characteristic of the DRAM is the DRAM. In DRAM, the data is erased automatically. It is because of the characteristic of the capacitance. If you charge the capacitor discharged automatically when the time passed. So if you write the data in the capacitor and the time passed, the data automatically erased. So we have to refresh the DRAM regularly to check the data is okay. So if you check the capacitance and if there are data, you have to rewrite the data once again, and if there are no data in capacitor, we just pass. We call this process as refreshing. But if you refresh the DRAM too oftenly, it means we have to waste the power too much. So to make a good DRAM, we have to increase the capacitance of the capacitor. The last device is flash memory. Flash memory is the device in the group of ROM. This is the basic structure of the flash memory. It is very similar with MOSFET, but we have to add some floating gates in the between of the control gate and the body. The flash memory use the principle of tunneling. If you apply very strong bias in the control gate, the thickness of the oxide becomes smaller in the edge of the oxide. So in the edge, the electrons can tunneling with this area. So tunneling the tunneled electrons move to the floating gate, and the floating gate is the material which is stuffed heavily, so you can save the memory at here. So this is the IDV curve of the flash memory. If the floating gate is charged, you have to apply more strong bias in the control gate to make a channel. So it means the threshold voltage shifted to here. So if you check in this line, if there are many current in this voltage, it means there are no data in this device. But the current in this voltage is very low or no current in here, it means there are data. Today we talked about the three memory devices, and thank you for listening.